In this video, we want to prove that equal chords of the same circle are equidistant from the center. And here we have a diagram where we have two chords AB and PQ, and the center is O, and we have drawn perpendiculars from O to PQ and AB. And why have we drawn these perpendiculars? Is because we know that the distance or the shortest distance between a chord and a point or a line and a point is the perpendicular distance, and that's why we have drawn the perpendicular distance. What we need to prove here is that if PQ is equal to AB, then OM is equal to OC, right? So this is what we need to prove. How are we going to do this? Is first of all trying to collect all the information that we have. What I can see from the diagram is that clearly PQ is equal to AB because it's given to us. We are going to use a knowledge point that the perpendicular drawn from the center of a circle to the chord bisects the chord. So from our knowledge of geometry, we know that M is a midpoint of PQ because OM is a perpendicular from the center of the circle to the chord, and similarly C is the midpoint of AB since OC is the perpendicular to AB and O is the center of the circle. And with all these knowledge points, let's see if we can prove OM is equal to OC. Now let us first of all try and complete a triangle. And why I like to draw the triangles in such circle proofs, because if I can complete a triangle where OM and OC are the sides of those triangles, then it becomes easier for me to prove that the triangles are congruent, and then I can show that OM and OC are congruent. And because I can see different elements that are already equal, I think this approach of making a triangle first and trying to show them congruent is going to work. So we have completed two triangles. One of them is triangle OMQ and the other triangle is OCB. So we mentioned in triangle OMQ and triangle OCB, what we see is that there are two right angles. One of them is OMQ. Major angle OMQ is equal to major angle OCB, and both are equal to 90 degrees. And we know this from construction, right? Because we already know that these are perpendiculars, so the angle is 90 degrees. So can we say that the triangles that we're considering are right angled triangles? Now we go ahead. We have already mentioned one of the points. The next point that we can consider in both of these triangles is side OQ, right? OQ is equal to side OB. And why is that? This is because both are radii of same circle. And we already know that the radii of the same circle are equal. So we already got the second point in the two considered triangles. Now let's see if we can find something else. We already know that PQ is equal to AB, right? And therefore, the half of both of them should be equal as well. We already know M is the midpoint of PQ and C is the midpoint of AB. And therefore, can I say PM is equal to MQ? And because both of these chords are equal, I can also say that this is also equal to AC and BC. And we only want to highlight MQ is equal to BC, right? And so we will just keep MQ and BC here, right? Let me just write it well. So MQ is equal to BC. And I can say this is deduced knowledge from the fact a perpendicular drawn from center to the chord bisects it. You won't really have to write such a long reason in the exam, but I'm just writing it for you to understand. This is a deduced knowledge from the given point as well as something that you know from the geometry. So we have got three elements in the two triangles that we considered to be congruent or to be equal, and it is enough to show that the two triangles, triangle OMQ is congruent with triangle OCB. And which test that we used here? We showed that these both are right angle triangles and the hypotenuse OQ and OB are equal, right? So this was the hypotenuse, right? And we already showed one other element of both the triangles to be equal as well, which is MQ equal to BC, and therefore this is hypotenuse side test. And since triangle OMQ and triangle OCB are equal, all the other corresponding elements of both the triangles are going to be equal, and therefore OM corresponds to OC. I can say that OC is equal to OM, And this is exactly what we wanted to prove at the top. And therefore, the equal chords of the same circle are equidistant from it.